Okay, so on page 30, we're going to take a look at some practice problems for all of the different factoring strategies that we've seen in this unit. So we've seen taking out a GCF, we've seen grouping, we've seen the AC method and guess and check, and we've seen, as of your homework last night, difference of squares. So that's what we're going to take a look at for today. So we're just going to go through our problems on page 30. So if we start with number 1 up at the top, what's the first thing I always want to look for when I'm factoring? Very first step, no matter what kind of problem it is. Look for a greatest common factor. Do I have a GCF here? No, I don't have any factors common to all of those terms. There's no GCF for me to pull out. So now I'm going to look at how many terms I have. How many pieces are there here? 3. So what strategy am I going to use if I have 3 terms? Stretching, okay. Not difference of squares. It's the one you guys looked at last night. 3 terms. It was new to us earlier this week. Maybe if I flip back to page 27, that might jog my memory. Yeah, the AC method, or guess and check if you'd like. Since we have a lead coefficient here that's not 1, I'm going to use AC method for problems like this. If you prefer guess and check like what we did in Algebra 1, that's absolutely fine. But what I saw from Algebra 1 is that several of us struggled to correctly factor problems that had a lead coefficient that wasn't 1. So I'm going to use this other strategy to give us a little more structure and a little more success with these problems. So I'm going to use AC method here. So 3 times -5, be careful of your signs. 3 times -5 would give me -15. And now I want factors of -15 that add to -2. What factors do I want? Yeah, it's nice when it's the things I multiplied, right? Because then it's like already there for me. So -5 and 3. That means I'm going to rewrite this, keep the first term the same, so 3x squared, by splitting up the middle using the factors that I've chosen. So -5x plus 3x minus 5. That end term stays the same as well. The ends stay the same. It's the middle that we change. Now I've rewritten it so that it has 4 terms. And how do I factor stuff that has 4 terms? In groups, yep, grouping. So here's my first group and my second group. And again, the order for these middle terms does not matter, okay? Your sort of middle step is going to be a little bit different if you put it in opposite order of what I have here. If you have plus 3x minus 5x, your next step will look different, but we're going to end up with the same factors. So what's the GCF for my first group? Yeah, just x. What's left over when I factor out x? 3x minus 5. What's the GCF for my next group? Just 1. If there's nothing exciting to pull out, we just pull out a 1. So then left over, I would have that same 3x minus 5. Remember, I always want that step in parentheses to be the same because this is now my new GCF that I'm going to pull out, the same as I pulled out x here. I'm going to pull out 3x minus 5. And then left over, I have x plus 1. So there's my factored form. Questions for me on that first one? Okay. Just as a reminder, factored form shows us the x-intercepts for our function. So we'll come back and put some more emphasis on this a little bit later once we're a little more comfortable with the factoring. But remember, I would get x-intercepts from this guy. Okay, so we'll do that for this one, but I'm not going to worry about it for the rest of these. My x-intercepts from this guy would be -1. And my x-intercept from this guy would be +5/3. Again, we'll put more focus on that a little bit later. For now, I want to make sure we've got the factoring part down. How about number 2? Grouping, yeah. First thing I always want to look for is a GCF, but we don't have a common factor for all of these terms. So since it's 4 terms, we're going to use grouping. There's my first group and there's my second group. What's the GCF for my first group? Perfect, 5x squared. What's left over when I take out that 5x squared? X minus 2. How about my second group? What's my GCF there? 3. What's left over? Good. And now what's the next thing I'm going to pull out here? Yeah, x minus 2. My stuff in parentheses is the same, so I'm going to pull that out. And what's left over? 5x squared plus 3. Good. Now, when we first looked at our grouping problems, when we had a factor, or once we got 2 factors, I should say, we stopped. Now that we know how to factor difference of squares, I want you to take a look at any factors that still have an x squared, okay? And check to see if it's a difference of squares. So we've got a factor here that still has an x squared. Difference of squares means it should be subtraction, right? That's what difference means. Is this subtraction? No, so we'll leave this one. And then if I kept poking at this, 5 is not a perfect square and 3 is not a perfect square, so I don't have a difference, I don't have squares, there's nothing else we'll do with this one. But you will see problems where we'll factor by grouping and then we get a difference of squares as one of our other factors. And we'll keep factoring anything that we know how to factor. Okay, so for this one we're done, but I want this to be on your radar. If you factor and you've still got an x squared, check to see if you can factor some more. Okay, let's take a look at number 3. What do I have going on here with number 3? Sort of. What's the very first thing I want to do when I factor? GCF, right? So right now, I've got even degree in 2 terms. This looks a lot like it might be something that you took notes on last night, but pull out your GCF first. What is our GCF here? X. So if I factor out an x, I'd be left with 8x cubed plus 1. I don't have an even degree anymore. This right here in parentheses is something that we would call a sum of cubes. Sum because it's addition, and cubes because these things are all perfect cubes. But that's actually not something that we're going to worry about factoring in here. It's nice for like 3 problems that we might want to do together, but it's not something that we're going to focus on right now. So for right now, we're going to say that our factored form for this guy is x times 8x cubed plus 1. Do we see why we wouldn't do difference of squares on this thing? Okay, it's not a difference. This guy is not a perfect square of something. It's not an even degree after we pull out that GCF. Before definitely was even degree. So good that we're thinking about that. But I got to pull out the GCF first. How about number 4? Is there a GCF there? Nope. So it's 3 terms. What do I want to do? AC method, or we could use guess and check on this one. So for AC method, that's where we had something that was a lead coefficient that wasn't 1. So we did A times C and we rewrote the middle. For this guy, since the lead coefficient is just 1, if I did AC method, it would just be 1 times negative 90. So at the end of the day, we're just looking for factors of negative 90 that would add to 1. Factors of negative 90 that would add to 1. Negative 9 times 10, that would do it. Yep, negative 9 times 10. Now you can go full out AC method on this one and rewrite the middle, but what we're going to end up seeing is that our factored form is just going to be x minus 9 times x plus 10. So if my lead coefficient for a trinomial is just 1, I've got the factors I need right there. If I've got a number in front of x squared that's not 1, do the AC method. Questions on number 4? Okay, let's take a look at number 5. What do we have going on with number 5? Two terms, even degree, subtraction. You told me a minute ago. Yeah, difference of squares, right? This is a difference of squares. Two terms, even degree, subtraction. So what I'm going to do is rewrite this as each part squared. Each part is something squared, because that's what I need to know. I don't need 9. I need what did I square to get 9. So what did we square to get 9? 3. What would I square to get x squared? X. Yeah, that kind of seems like a trick question, but it's not. What would I square to get 1? 1. So my factored form here would be 3x plus 1 times 3x minus 1. Questions on number 5. Let's take a look at 6. What are we going to do for 6? Grouping. Very good. 4 terms, we group. What's the GCF for my first group? Very good. What's left over? X minus 1. How about my second group? 2. What's left over? And so then what's my factored form from here? What's my next step? I'll say. X minus 1, pull that out. And then x squared plus 2. Yep. Now, one of my factors has an x squared, so I want to check to see if I can factor this some more. 2 terms, even degree. Is this a difference of squares? Difference means what? Subtraction. Difference means subtraction. Do I have subtraction here? Nope. So we're going to leave this one as it is. Okay, let's hop down to number 7. What do we have going on with number 7? Sort of looks like a difference of squares. What's the first thing I want to do? GCF. What's our GCF here? 4. Very good. I have a GCF of 4 here. When I factor out 4, I'd be left with 8 x cubed minus 27. Okay. And then I heard a couple of people say this looks like last night's homework. 2 terms, subtraction, but what about our degree here? Not even. It's an odd number, right? So this is a difference of cubes. 27 and 8x cubed are both perfect cubes. Kind of like we had that sum of cubes up here. So there is a way to factor this. You have to use a little formula. We're not going to worry about that for right now. We are just pulling out that GCF, okay? That's all we're going to worry about for right now. Check to see if you can factor it. We can't, so we're going to leave it like that. How about number 8? I have a GCF of 6. There's actually another piece to my GCF that I can pull out here. 6, and then 32, can I divide that evenly by 6? 18 you can divide by 6, but not 32, right? So it's not going to be 6. I can divide both of these numbers by something. So something x I'm going to pull out. 4 goes into 32. Does 4 go nicely into 18? No. So what are we going to end up taking out here? Just 2, yeah. So this would be a GCF of 2x. When I factor out 2x, I'm left with 16x squared minus 9. And now we still have an x squared here, so let's check this guy. Can I factor this more? 2 terms, even degree, subtraction. This is set up perfectly for a difference of squares. So let's see if we can figure out what we squared to get each of these parts. What would I square to get 16? 4. And to get the x squared, what would I square to get 9? Okay, so As I finish factoring this using that difference of squares pattern from last night's homework, this would be 4x plus 3 times 4x minus 3. And then last thing here, don't forget we pulled the GCF out at the beginning. So I need to drop down this 2x and include it as my GCF in my final answer. Questions on number 8. Number 9, do we have a GCF here? Nope. 3 terms, what am I gonna do with this thing? AC method, yeah. And I'm gonna go ahead and do the full AC method since we have a lead coefficient that's not 1. So this would be 4 times 1. That gives me 4. I need factors of 4 that add to negative 4. Factors of 4 that add to negative 4. What did we say? 2, 2 and 2. And then 2 times 2 would give me positive 4. They would add to positive 4. I want them to add to negative 4. So what change do I need to make here? Make them negative. Yeah, negative times a negative would give me a positive. If I add them, I would get negative 4. So for my AC method here, keep that first term the same, 4x squared, and then minus 2x minus 2x, and then keep the last term the same. Now that it's 4 terms, we're going to group. What's the GCF for my first group? 2x, very good. What's left over when I factor out 2x? Yeah. And then how about my second group? What's the GCF there? Nothing exciting, so I'm going to do 1, but I want you to notice that my group starts with a negative. So I'm actually going to factor out negative 1 here. Because if I just factor out 1, that would leave me with negative 2x plus 1 in parentheses. And I want the stuff in parentheses to match. So do we see how those signs would be wrong? Yeah, so I'm going to factor out negative 1. And that's just going to change the signs here to positive 2x minus 1. If you're factoring and these match, but the signs are different, like the term, you've got the 2x, you've got the 1, but the signs are off, double check your signs as you pulled out your GCF. Maybe you wrote negative 1, but then didn't actually change those signs. Or maybe you didn't factor out that negative 1 and you need to change it so that you are factoring out negative 1. Now that these are the same, that's my new GCF that I pull out. And I'm left with 2x minus 1. Is it okay that I have the same thing twice here? Sure. I could also, if I wanted to, write this as 2x minus 1 squared, since I have 2 of the same factor. And we saw an example earlier in our unit where we did that. Questions on number 9? Okay, our last one on page 30. Do I have a GCF here? Nope. It's 3 terms, so what am I going to do? AC or guess and check? Yep. So since my lead coefficient is 1, I'm going to use sort of that abbreviated AC strategy where we don't have to go through the whole rewrite and the grouping. So 1 times negative 12 will just be negative 12. I need factors of negative 12 that add to negative 1. Factors of negative 12 that add to negative 1. Negative 4 times 3 would do it. Very good. So then as I factor this, I would get x. Now, there's something else different about this problem. Before I put the x, before I do anything else, see how we had x to the 4th here, and our middle term is x squared? That means that this guy is going to be x squared, not x. If this were x, when I distribute back, I would just get x squared, and I would have a degree of 2. But I need x to the 4th, which means I've got to have x squared times x squared. So this would be x squared minus 4 times x squared plus 3. Does that make sense why I'm using x squared? Remember, when I distribute back, I should get the original problem. So I need x squared times x squared to get x to the 4th. And then my middle term would be x squared, guys, which is what I need for my middle term. Now, since my factors both have x squareds, I want to check to see if I can factor them some more. So 2 terms, even degree, subtraction. Can I keep factoring this guy? Yes, we can factor this as a difference of squares. What did I square to get x squared? X. What did I square to get 4? 2. So this would factor into x plus 2 times x minus 2. Now, how about this other guy? 2 terms, even degree. Can I factor this guy some more? Ooh, I've got mixed answers on this one. Yeah, not subtraction, right? This is not a difference. And then 3 is also not a perfect square. So I'm stuck with x squared plus 3. So we'll just drop it down here to be part of our final answer. Questions for me on number 10? Okay, so tomorrow we're going to start class with some review problems, refresher problems, a couple more factoring problems that we'll do together. And then you have a short quiz over just factoring. That's why I didn't focus so much on the x-intercepts today, because your quiz is just going to be like the bare bones basics of factoring. I believe it is 6 or 7 questions. So it's not very long. I'm looking to see, can you use each of the strategies that we've looked at? And then can you take it for a couple problems? Can you take it one step further and recognize, hey, I factored, but there's a little more to do here, okay? So the bulk of your quiz is gonna be, can you use AC method? Can you use grouping? Can you pull out a GCF? Can you do difference of squares? And then I believe you have 1 or 2 problems that are a little more similar to what we did in number 10, where we used like AC or guess and check, and then we had to also do difference of squares, okay? If you can do the basics, it shouldn't be bad. To help you make sure that you're ready, you have an assignment on Delta Math that is everything that we've covered so far, okay? So go ahead and start that now. Finish it for homework if you need to. Tomorrow, we're gonna start with a few problems again together, and then you'll have your quiz in class tomorrow.